Hi, so I'm going to go ahead and post Chapter 7 a little bit early so that y'all are able to accommodate your schedule. As we're going through the slides, you'll see that some of them already have the text written in. That's just so that I was able to speed up the process, otherwise it ended up being a little bit too long for my Dropbox. Same as with Chapter 4, I will divide this into 2 videos. So this is the first video that's looking at the free response questions, and then I'll have a second video that's looking at the multiple choice questions. So first one says list and explain 3 serious problems associated with consumer interviews or surveys. Give an example of each one. So first is that the sample may not be random. For example, if you're interviewing individuals on a flight, you may interview all the first class versus all the passengers. Response bias, if you ask people how often they floss, they're more likely to say, yes, absolutely, I floss 2 times a day, than actually give you the true response. And 3, unable to respond accurately. So sometimes you really, truly don't know how you would respond because that's not the way individuals logically think through something. So for example, if you're told the price will increase by 10%, it's really hard to actually know how your behavior would change. The next one says the estimated market demand for good X is Q hat equals this. Is X a normal or an inferior good? Explain. It is a normal good. And the reason we know that it's a normal good is because the number in front of M, which is our income, is positive. So the positive 0.225 is greater than 0. Are they substitutes or complements? They are complements. And the reason we know that is because the number in front of our other price is negative. So then it gives us some information. It tells us at P equals $22.50. Income is $43,499. Price of our alternate good is $12.50. Compute estimates for the price, income, and cross price elasticities. And before we can do any of that, we need to solve for Q using this information. So we are going to solve for Q hat, and that's 16,784. And all this is just copying the demand equation. And then we're going to substitute in the information that we've been given. Right here. No, we're going to run out of space, so. And the reason we have to do this is because in order to find the elasticities, all of the formulas require that we substitute something in over our quantity, and we're not given the quantity. And when you type that into your calculator, you get 1015.35, which will round to 10150.4. And then we have 3 elasticities. So our own price elasticity is going to be partial Q partial P times P over Q. And this partial Q partial P is just looking at the part in front of that variable in our equation. So negative 232.43 times 22.5 divided by our quantity. Which gives us negative 0.5152. Our income elasticity is going to be the same thing. It's going to be partial Q partial N times M over Q. So we're going to take the number in front of the M. So 0.225. Times 43,499 over 10,150.4, which is going to give us 0.964. And then the last one is our cross price elasticity, which is going to be partial Q partial PZ times PZ over Q. So negative 895.3 times 1250 over our quantity gives us negative 1.10. So the big takeaway when you're looking at these is to go slow. Make sure you don't make stupid mistakes and mix up the numbers like I almost did when I was calculating the income elasticity. The formulas are very repetitive, so as long as you keep track of what you're trying to do, it's not too terrible. Next one says we have an empirical demand function estimated in log linear form. What's great about log linear form is that there's substantially less work to calculate elasticities than there was on the previous problem. First one says is X a normal good or an inferior good? And the way we are figuring that out is we're looking at the coefficient in front of our M. Since it's negative, it is an inferior good. Meaning that as income increases, the quantity will decrease. Are X and Y substitutes or complements? They are substitutes. And we know that because the value in front of our other price is positive. So as the price of our other good goes up, and we are going to buy more of this good instead. Express the empirical demand function in the alternative non-logarithmic form. So we are going to have Q hat equals $15.6 sorry, it's a comma, not a point. times p to the negative 2.85 times m to the negative 0.05 times py to the 0.35. On the next slide on the PDF, I will post how I got this starting number in case you don't remember all of your logarithmic rules. That's totally fine. I completely understand. D says at p equals 10, m equals 55,600, and py equals 12, what are the estimated cross-price elasticities? And then what is the predicted number of goods demanded? So we're going to start with that just because that's what we did first last time. So we're going to have q hat equals 15,670, 175. P raised to the negative 2.85. M raised to the negative 0.05152. Py raised to the 0.35. We're going to substitute everything in. And when we do that, we will get q hat equals 30,083. Our elasticities are really nice coming from the logarithmic form. Our price elasticity is just negative 2.85. It's literally just the number in front. You don't have to multiply it by anything. Our income elasticity is just the number in front of our m. And our cross-price elasticity is just the number in front of our y. So the next one says a linear trend for the sale of the form was estimated. Is the sign of b hat as b would be predicted theoretically? So we're going to substitute in this information that we know. So q equals this minus 432.59p minus 0.0885m plus 126.35 PR. So yes, the number in front of our P right here is what we would expect. It follows the law of demand. If we are comparing it with good represented by PR, we know that because it's positive that they are substitutes. When we are looking to determine if they are statistically significant, they are all statistically significant because all of these p-values are less than 0.10. So using the values, calculate the estimates of. Since this is just a regular form, we have to go back to our other original calculations. And to do that, we need to know what our quantity is. And for the sake of time, I am going to tell you that the quantity is 16.705. It will be worked out on the PDF that is uploaded to Blackboard if you need it. So the price elasticity is going to be negative 432.59 times 48 over 16,705, which gives us negative 1.24. The income elasticity is going to take the number in front of our m, so negative 0.885 times 62,450 over 16,705, which gives us negative 0.33. And the cross price elasticity is 126.35 times 250 over 16,705, which gives us 1.89. Next one has a linear trend equation for sales of the form this. Using the information in the table, we know that this is the actual equation. So if we are using 0.05, then we are trying to decide if these are statistically significant. And looking at these values right here, they are both smaller than our 0.05. So A hat and B hat are statistically significant. Using this equation, forecast sales in 2020 and 2025. So we're going to have QT equals 4,430 minus 1.77 times 2020, which is going to give us 854.46 and 4,430 minus 1.77 times 2025 gives us 845.75. Make sure you pay attention to how it sets up the terms that it's looking at. Comment on the precision. The farther out that we're estimating, the less accurate it's going to be. Then the last one, I already have some of it worked out. So first, I went ahead and pre-wrote the equation. To determine our t-value, we're going to look at the number of observations, which is 32. We're estimating 5 parameters, so we have 27 degrees of freedom at 5%. This is the value if we look at our t-table. So we're comparing all of these, and all of these are greater than 2.052, so they are all statistically significant. We could also just look at the p-values and compare all of those to 0.05 and see the same thing. If we calculate the intercept in each of the 4 quarters, then we are going to use this. In the first quarter, it will be this plus this. In the second quarter, it will be this plus the coefficient in front of the dummy 2. In the third quarter, it will be this plus the coefficient in front of the dummy 3. And then we can use this estimate to forecast sales in the 4 quarters in 2019 specifically. And the way that they are estimating right here, we see that they are not using the years as the t. They are using 1, 2, 3, 4 all the way up to 32. So to get to 2019, our numbers that we substitute in are going to be 33, 34, 35, and 36, and the math is already typed out. If you have questions on the free response questions, please let me know. Hope you have a good week.